Thank you very much, everyone, for joining today. We're going to talk about open source license detection and license detection in general, and practical ways to deal with it, the issues, and some recommendations. So, quick words about me. I'm on a mission to make it easier to reuse free and open source software. And I'm the maintainer of ScanCode, Vulnerable Code, and several other projects, creator of Package URL, co-founder of SPDX, and a few other projects. I'm also the CTO, co-founder of Nextbee, your host today. So, agenda for today, we'll be discussing license detection, some of the issues with it, and some suggested ways to practically deal with license detection and license review and license compliance overall in your organization. Feel free to ask questions. I'll take the questions towards the end, either in a chat or as a voice your call. So, of course, why should we care? Why do you care about licenses? I think it's pretty obvious, but we often forget it, is that if you are not licensed, you may not be authorized to use the code. And the mere fact that it's published and visible on the web is not enough. In fact, the default license for code on GitHub just allows you one thing, is to view the code and nothing. So if there's no license, you are not licensed, you're not authorized. And when there's a license, you need to comply with licensing conditions. The good thing about open source is that most of the time it's fairly easy. You don't have the same complexities that you have in proprietary license, but you still have a few things to deal, like giving credits, this kind of things. And there's, of course, bad and other thing you need to care for, which is not the scope of today's call, but vulnerabilities, buggy code, unmaintained code, SBOMs. And all that are, of course, related topics. But in a way, you could say, if you don't know the license and you're not authorized to use it, everything else is less relevant if you're not authorized to use it in the first place. And that sounds a truism and pretty obvious, but open source is defined by licenses. In the beginning, there were licenses, and that's licenses that have made open source possible. And the big advantage of these licenses over proprietary license is that, well, there's probably a few too many, but if you think about how many proprietary licenses there are for software, there are millions. Eventually, every single contract may be unique. And for cookie cutter software, you may have common contracts, but otherwise, you end up having essentially one vendor, one software, one license. It's pretty daunting. So the big win to me with open source is not so much it is open. Of course, it's useful, it's essential, and it's critical, but there are a few well-known license terms. And if I say BSD, Apache, GPL, you know immediately what these references. You don't have to read pages and pages of license and contracts. You don't need a lawyer to figure out what are the license terms. So it's a big win. To me, it's the essential win of open source over proprietary. And furthermore, we've codified the identifiers with SPDX license identifiers. SPDX stands for Software Product Data Exchange. It's a Linux Foundation project. So that's where we are. Now, even though we have an advantage with free and open source software licenses, it's still a bit messy and chaotic. And chaos is always difficult to automate. So we're trying to find ways to automate such that things go out of the way and don't need as much attention as they need otherwise. Definitely, it's already less than what's needed for commercial license and proprietary license, but we want to go even further down. So the situation, we are all reusing more and more software packages. That's great because we can now literally build applications as if they were Lego. We take bricks, components, there are open source libraries and packages, and we can build really complex and awesome applications thanks to this. The problem is that we're starting to use a lot and a lot more. Typically, we've been at Nextbee providing professional services, among many other things, for merger and acquisitions and product audit releases to large commercial software organizations. And we see between 10 to 100 times more third-party packages being used in proprietary products or applications. And it's not uncommon to see an application that contains and embeds 10,000 packages. When you start to have that many, that means you potentially have 10,000 different origins, potentially 10,000 different licenses. Well, not exactly, because we don't have 10,000 open source licenses, but you may have many different combinations. And I wish that we had clear and good metadata so we wouldn't have to guess or detect or do any kind of detailed analysis work for each of these packages, but it's not there. Both origin, license, where we can find the source code, all these are sometimes missing. So we're entirely missing clarity in licensing. I did with Dennis Clark a small study a few years back on the clarity of licensing of the most popular open source package across 5 different ecosystems like JavaScript, Maven, Java, PyPI, RubyGems, and trying to look at the 1,000 most popular package in each of these and compute what we call a license clarity score. We'll come to this in a second. And the idea of clarity is to say, if it's clear, you don't need to further dive into the details of each files that exist in the package or project. Here, there was no ecosystem really that had popular packages that were with a high level of clarity. None of them was able to provide, on average, complete and comprehensive license documentation. There were a few brighter spots. JavaScript, which tends to have smaller packages, so they're easier to document, had slightly better overall clarity, but still very far from where we'd like it to be. So there's maybe a bit of light at the end of the tunnel. It's messy, but at least we have not only fewer license than proprietary code, but also we've defined a decent way to talk license, and that's with SPDX license expressions. We have codes for license, we have expressions, and a syntax, which means we can use concise and accurate ways to present the license. I can say, this is under GPL 2.0 only, or MIT. This is enough to convey a choice of license which are backed by eventually large text with thousands of words that you can abstract in a few words. That's really useful, and that's a way forward to further abstract and simplify how we can deal with licenses. The other thing is that the evolution of license detection tools and techniques, I know some of it because I'm maintaining some of these, I've reached a point where they start to be really useful and helpful. Uh, the other thing also is that there's a lot of hype around SBOM, software bill of materials, mostly around security and the requirements to provide the accurate inventory of third-party packages, so you know which one are vulnerable. But it also highlights and heightens the visibility of these software packages and the need to get clear licensing information when you convey an inventory of package to a third party, an SBOM, bill of materials, so an inventory, conveying also that you have the rights to use this software is eventually something which is not too bad. And so there's a positive, I'd say, feedback and interplay between the requirements for security and the requirements for compliance, license compliance, even though they may be otherwise fairly orthogonal. So what's the plan to fix this thing? We're going to go through assessing a bit the many different ways that open source projects document their license and copyrights. Mostly license, we'll just do a very brief short stint on copyright. And we see how we can detect all the license more accurately. And I'll provide a set of rules, 5 rules, which taken together is something which you can practically apply even in a small organization, a small team, to reach a very high level of license compliance without much red tape, fuss, and complexity. And we'll discuss also about a few next steps and how in future we would want to find ways to fix all the license. So the issues of clarity we've discussed are just gone entirely. So discussing the many ways of licensing, we're looking at different ecosystems. I have 3 slides on that. I will not go through each of them. Is if we look at how each package ecosystem, Python, Ruby, Apache, Java, the most common ones, Linux distribution, NPM for JavaScript, each of them have their own conventions to document license. And you can see some of it. Some of them use strings, URLs, SPDX expression. Some say we'd love to, or we'd like you to use SPDX, but they don't enforce it. Some of them just provide a field, say license, and it's fair game to put anything. It's a bit all over the map. Even Linux distribution, which have a bit more priority in the domain and have gone looking at package license for a long while, are still struggling with this. There's an ongoing effort, for instance, in Fedora to do an extensive review of the license and license codes which are used and eventually trying to adopt SPDX expressions. Popular language like JavaScript and NPM, it's either an SPDX expressions, but they have custom extensions, or it can be a list of strings, or it can be an object with name value pairs and types and URLs. And again, there's a lot of history behind all these, and I'm sure there's a reason. But as a user, it's difficult to make sense of all of these. And each time you don't have clarity and structure, you have ambiguity. If we look at some other domains like Android, they use their conventions with specific files. R, which is a language for statistics and math. It's interesting because you see actually how their domain, math and statistics, influence their approach to providing information on licenses. They use mathematical expressions to say it's LGPL, but superior to version 2 or inferior to version 3, which means LGPL 2.0 or 2.1. But it feels weird when you look at it from the outside, but it's just yet another way to deal with this. Some distros are using their own ways and own license ID. FreeBSD more recently is switching to using progressively SPDX license expressions. Popular container OS like Alpine recommend to use expressions from SPDX, but they're not enforced. And remember, each time you don't have enforcement of a convention, it's likely people will not comply or will not use this convention consistently. It's all over the map. Some more recently popular programming language like Go went all the way to say, well, we don't have licensed metadata at all. We don't provide that in the structured manifest information. You should just have a file called license, and that's it. It's obviously a way to say, we give up because we cannot cope with the complexity. It has a nice side effect, at least it's a bit less messy. It's a bit less messy, but there's still a problem, which is how do you get concise license information? So they go after that, they go detecting licenses in each of the packages, which is in turn not as good as it could be if it were specified explicitly. Another popular ecosystem, which is NuGet for Microsoft.NET and C# and related languages. They use a license URL or an SPDX expression or file path. In practice, the quality, breadth and depth of license expressions and license information NuGet is very, very low. I was about to say other words, but let's just say it's slow. So as a user, if you use package in any of these ecosystems, you're in trouble because this is really weird. Now, on top of this weirdness, we have witty users. I was involved firsthand with an effort a couple of years ago to clean up the license documentation of the Linux kernel, working with Thomas Gleisner and a bit Linus Torvalds and a few others, key maintainers. We found out running scan code on the whole kernel by then that there were 600 different ways, actually, I think it was more than that, maybe 800 ways to write a GPL notice in the Linux kernel. Of course, it's been out there for a very long while, since 1991. There's a lot of files, about 70,000-ish, but still 600 ways to say this is under the GPL. There's only a certain number of words that you can use and combine in different permutations. To add insult to injuries, we found really funny, witty, and in a way funny things, but when it comes to legal terms, it's difficult. For instance, the thermal driver code was licensed under the terms of the GPL. Funny, witty, but the problem at scale is if you have many of these variations is what does it really mean? Does it have a legal implication? Or another example elsewhere, an external out-of-tree kernel module, which was using an obfuscated module license tag, and 4750 4C20 blah, 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 means GPL v2 in ASCII codes. Obviously, this is not the best way to provide documentation. It still means GPL, there's no ambiguity about it, but most tools would just say, I have no idea what it means. Or it could be extremely terse. For instance, just say, hey, this is GPL. Of course, these 5 characters are enough to conclude that this is a GPL license, especially when it's used in the context of the larger Linux kernel. But that doesn't help. GPL could be the name of a company in Guyana which deals with petroleums and petrol. And that's the case, actually. So it's likely that the context will inform about what GPL means, but it's a bit terse in many cases. Now, to sort and escape this mess, I've built and we've created different generation of license detection engine. That's the one used in ScanCode today is the fifth one. And originally the idea was to say, we're going to create mappings. You know, saying if you have this text or this mention, that it means that. The problem is that it's difficult to do that on a large scale consistently. We were using regular expression at the point of time and many different techniques. There's very different convention that exists across the board. Of course, OBDP is not great, but eventually we ended up writing the current iteration of the ScanCode license scanner, which deals with about 2,000 licenses. They're both open source, many proprietary licenses, in contrast with SPDX, which has about 600. So there's many more licenses beyond SPDX. It's important because some license we track will never be in SPDX ever. For instance, SPDX doesn't track proprietary licenses, doesn't track public domain licenses at this stage, or public domain notices and dedications, as an example. And we track a large number, probably a bit over 30,000, maybe 35, it's growing on a regular basis, of example of notices as we've seen them in the wild. And these are notice, short mention tags that together are used to build an index similar way to the Google search engine index. It's essentially the same problem. The difference is that Google has petabytes and petabytes of internet content indexed. And what you query is limited to 32 words. You cannot search more than 32 words at a time in a query you do on Google. In our case, it's a bit different. The index is in the range of tens of megabytes, so not crazy big, definitely not petabytes. But what you search is not 32 words, it's your whole code base, which could be gigabytes of source and binaries. So similar principles, very different implementation, because the relationship between the size of the index and the size of the queries are completely inverted and different. We like to think the problem is mostly solved. It's not really there yet, but at least we're proud to see that ScanCode Toolkit is the industry-leading tool today in the space and really the benchmark for everything. There's a lot of discussion these days about ChatGPT and AI and machine learning and large language models. The problem is that I don't think any of these are able to deal with the specifics and minutiae of very short things like that accurately. And the thing is that it's what matters. It matters because of this, for instance. This is the license scanner used by GitHub, which is, for practical purpose, a toy. No offense meant, but it's a toy, which is very nicely telling you, oh, this package here is under the MIT license, except this license has been tinily modified by its owner. I don't know why. That's not the point. The point is that it's been changed by adding the word not. And permission is hereby not granted. Makes a big difference from a legal perspective. Whether it's a joke or not, doesn't matter. The point is that license detection cannot accept imprecision and inaccurate detections. So that's one problem. Other one is the lack of coverage. When we did these detailed scans of the Linux kernel, there were other open source tools that were used to scan the kernel, and we were comparing the results side by side. out of the files that contain license information on the 70,000 Linux kernel files, there were about 16,000 that were not detected. That's a lot. So the ability to cover a complete code base on the one hand and do it accurately on the other hand is really essential there, because if you have 16,000 files that are not detected, you'd be better off not doing any license detection at all. And you cannot rely on tools that are providing, with a lot of assurance, a result that's incorrect. I'd rather have something which tells me nothing than something that's incorrect. And why do we have this kind of issues? The core is that you can have exact detection tools which do a full and exhaustive diff between license mentions and the code where we find these mentions and notices. That's what ScanCode does. So it's an extensive diff. Or you can do a statistical comparison, where here the tool essentially says, I'm going to count the number of words that match between this text and the MIT license. And if it's 99%, then I'm good. Statistics are the essence also of machine learning. And that's why it's unlikely you will get any kind of ChatGPT-like and AI or machine learning-based system that's able to provide this level of accuracy, because you cannot accept kind of approximate average answer based on stats. It has to be based on an exact and accurate matching to license and their variations, which there are many. But you cannot afford to have this kind of inaccuracy and imprecision. Okay, so now, license clarity. I discussed earlier on about how we've built a way to deal with license clarity. And let me show you a few examples. So I'm using ScanCode.io here. It's an open source tool. I've scanned a package which is called Cloud Query. And it's a Go package. It's overall on an MPL Mozilla Public License 2.0. There are a lot of other licenses there in this, right? It's complex, large. And what we have here is what we call the license clarity. So license clarity is composed of scoring elements. Do we have a declared license? Meaning, is there a top-level license declaration which says this package is under the MPL 2.0? And the answer is yes. Is the precision of the detection of all the license acceptable? So it's about really the quality of the license detection that's done. And in this case, the conclusion is also yes. So we're looking at all the detections done and whether they are accurate or not. Do we have the license text for the main declared license and the other license present? And the answer is yes. Do we have declared copyright? We don't have that. So that's also 10 points. So we don't have 100 score out of 100. And we don't have ambiguous or conflicting license categories there. Therefore, we have a score of about 90. Is it okay to go with it? It's going to be a matter of policy. But the point is that this score has been designed such that when you look at a package, you should be able to determine mostly automatically if you want to look further at the details. This is an example of a smaller package. This time it's a JavaScript package. We can go look at it on another angle, the details of the data for this package. We could look at its homepage and all the good stuff we collect for this package here, of course. We see it's MIT license per GitHub. And as we've seen before, it's okay to go trust, but you absolutely need to verify, and you need to run scan code, because otherwise you're going to get in a mess there. So that's the details on the package. If we look at the license clarity here, we have a declared license. It's accurately and precisely detected. We have a license text. We have a declared copyright. We don't have ambiguities otherwise. It's a much simpler package. I mean, we literally have 6 files, 10 dependencies. So it's pretty straightforward, and we could look at the details of each of these, for instance, to see where it's been detected. Well, that's obvious, okay? It's MIT license and MIT. If you were to scan the package that is not granted, you'll see that it's slightly different there. And copyright. So nothing super crazy here in terms of complexity, but it's useful that you can go and look at these in details, or as is the case here, see the declaration that exists in the package manifest. But really, what it means here? The tools is telling you this package is under GMIT, and there's zero reason not to believe it's not, because all the informations are reinforcing each other, whether it's file level, declared level, presence of license text, and so on. So this is designed such that if you have a package that's detected with such a license clarity score, then you probably can go and decide it's okay. We at Nextbee do that, and we recommend you to do that in most cases, because it's as good as any manual review that we would be able to do on the details of the results of the origin and scan that was done there. So that's one thing, license clarity, which is an important tool to escape the mess of that exists in terms of inaccurate license detections. And beyond this license clarity scoring, we have also done extensive use, in this case, of some machine learning to figure out what are the false positive detections, or not false positive, but imprecise, and how we could remove and resolve some of these to further lower the level of review that would be needed. For instance, if you have a detection which says this package is licensed under D, just that, scan code may detect that as a statement that should introduce license. And it's great because it may not know about the license that come afterwards, or it may be detected as unknown, but at least we know it's an introduction for a bona fide license. It should be introducing a license notice. And then if the license that comes after that, it says DMIT license, then you can effectively combine these two in one statement, which says this package is licensed under the MIT license. And you've removed an ambiguity about a license introduction, which was a clue, but really wasn't interesting otherwise. That's one of the many examples. Something as mundane as having many different detection of the same license in one file can be conflated in one. If you have 5 detections of MIT, then it's as good as one detection of MIT. We're also working on an upcoming option which we call To Do, which is going to tell you what needs review in terms of license. So it's based on license clarity and other clues to determine whether a human review will be able to get better at a conclusion than what the tool has been doing. So it sounds a bit of hubris on my side to say we can determine what you need to review, but it's really about, based on experience on licensing and the detection accuracy and the clarity score, and whether there's any ambiguity or unknown license detection that would need some attention on your side. We've discussed copyrights, so very briefly, it sounds like it's a simple issue. After all, there's only so many ways that you can combine the word copyright, a date, and a name, except that in practice we have thousands of different ways that a name, a copyright, and a date can be written, combined together. We did write a natural language parser and tool with a grammar specialized for this to detect all the different variations. It's not perfect, but it's definitely the very best tool in the space. It doesn't have any equivalent. Most everything and everyone else is using a few regular expressions, which are extremely brittle and miss most of the time the proper copyright. The other thing that's important is we're able to extract the copyright holder from these copyright mentions. We use also statistics on these copyrights and the prevalence of an holder versus another one to provide a primary holder when we can. Here, that's an example of what we do. We have other examples elsewhere. Well, that's an example where we're not able to find one. That's another example. The point is, we are able to do that in many cases. So let's go now briefly in 5 rules that I think should be really the base and the essence of what you can use to create an efficient, effective, and minimalist license compliance program in practice. I'm a software developer too, so I understand that many times as a developer, license is the least of my problems. But one thing that should not be my problem is to keep track of any existing notices. If I borrow some code, golden rule, keep track of that. We use a convention and a set of practice we call about files in Nextbee, and I could explain that another time. It's part of our open source tools, just small files which keeps details of origin, license, copyrights for any third party we use as a library or that we copy and vendor in our code base. In all cases, keep track of everything. It's a very simple rule. It's very easy for developers to apply. Keep track of origin, keep track of notices, add them back if they were missing. The point is that we cannot detect what does not exist. So if you start by losing information at the beginning, you're lost. It's like when you do lossy video compression, you cannot ever recover the quality of the video when it's been compressed and you've lost information. You don't want to have that lossiness. Rule number 2, you need to define a simple policy. Policy is which license or license combination are acceptable to your organization. And you may be developing open source tools, you may be developing proprietary tools. Your policy may be different, and based on your license and context, you may have different appetite for different licenses. A very simple one could be based on license categories, whether a license is permissive, copyleft, limited copyleft. And this would be an example, for instance, of a minimal, super minimal policy, which is to say, if it's copyleft, it's okay or not. And you may specify when it's okay to use as a tool in a separate process, for instance. That can be a few lines, don't need to be more, to be longer than this. Limited copyleft like LGPL, permissive license, and everything that would be funky and proprietary, typically, irrespective of your context, whether you're doing open source, GPL, permissive, or proprietary code, it's usually not okay. And if it has to be okay, it has to be reviewed on an exception by exception basis. So the good thing is that every scan code license comes with a license category. And you can literally have a 5 to 10 line license policy, which is going to be something which gets you a very long way. You can make it more comprehensive as you grow, but having something that simple is going to be a big service you'll do to yourself and to your developer teams. Rule number 3, it's open source, so please use the source. Keep the source. Make sure you keep track of the copy of every single source code of every package you use. It's good for engineering. It's good if you have a bug, if you have security issues. If you don't have the source, you won't be able to patch it. But beyond this, there's one aspect of open source which is to be able to comply. To be able to comply means redistributing the source code of copyleft license packages, providing proper attribution notice. All of these are in the source. And so just keep the source. It can be easily automated with scripts. And don't think you'll be able to find these after the fact. It's difficult. So it's really a mechanical operation. Figure out which package you use. Just keep an archive of the source. Rule number 4, which is to scan for licenses. You don't want to rely on assertions of toy tools like we've seen beforehand. You should use scan code for scan licenses. You can use the license clarity score, apply your policy on top, and trigger the review for anything that's out of the ordinary, whether it's a low clarity or outside of your policy. And that's going to go a very long way. You may have developers that may not be comfortable with doing this kind of review, but then having legal or engineering or an open source program office, of course, can help in this context. The thing, it doesn't have to be super complex. It's funky stuff eventually, if they need review, will go away of their own, because the red tape attached to looking for funky, out of policy and policy violations and low clarity will just mean that your developers will prefer looking at alternatives, and we'll keep this really for the important ones. And rule number 5, which is more the outcome of what's been done with the 4 previous ones, is to comply. And complying is eventually simple. It boils down to 2 things: providing credits, providing the source. Providing credits means generating an attribution notice, or more fashionably these days, what we call an SBOM, software bill of material, whether it's SPDX or CycloneDX. You can use scan code for this. Scan code, Abort Code Toolkit, Deja Code, all of our tools do this. If you were to look at this example here, this is a CycloneDX SBOM. It's pretty straightforward. You click on it, and you can attach this to your, it's taking a second to generate. You can also generate an attribution notice. I'm going to do that separately here. I'm using a demonstration system which may be down. We're going to let it run for a second. It's a small package, but it should be much faster. At least it's live demonstration. So you need to generate these. You can assemble them by hand, but generating is definitely the way. You can, oh, there we go. You can automate that as part of your release build. So it's a Cyclone DX software bill of material for this package. It's nothing super critical there. You know, it just repeats in a conventional standard format the fact that this is this package npm MIME type version 2.1.35, which is licensed under the MIT, which comes from this place and has this description. That's the bulk of what these are about. Attribution, we'll go and look at that in a second when it's done. There you go. That's an example of a generated attribution notice. You'll see essentially the same information together here with the full text of the license, which provides basically all the conditions that are enumerated in this license. You meet with both the spirit and the letter. Actually, we go a bit beyond because we also provide, even in this case, the download URL. So do this. It's not a problem if you over-attribute a little bit. It's okay. It's not the end of the world. You can be extremely precise if you want. And we have tools, especially in ScanCode.io, to make sure you know very precisely what is the subset of the code that is being included in a product package or application. If you look at this, and if you're ever fancy looking at ScanCode.io, when you're creating a project, you can create a new project here, and we have pipelines to analyze in details the makeup of many different type of code base, packages. And you could there get a very precise attribution. But in general, it's not a big deal if you overcredit. Nobody will blame you for this. And redistribute the source. You can piecemeal it and determine what is the subset of the source code that requires redistribution. If you don't want to bother with that, just redistribute or make available for redistribution all the source of all the code that you use, all the open source code, of course. And you can do that because rule number 2 or 3, you kept the source, which was essential for compliance, of course. And that's pretty much it. So beyond this, in the future, you could think of ScanCode as this kind of universal normalizer and translator for licenses, which takes all this mess and gives you normalized output. Or you could think of as a license linter. It's great to have this tool, but eventually we'd like to go upstream and fix it upstream, such that the information doesn't even need to be scanned anymore, but you have proper information upstream. So we're trying to work in different ways, expose ScanCode.io services for open source projects. We have a project called PearlDB to expose all this information normalized, and we want to work upstream. We're trying to do some campaign potentially with some large projects and open source ecosystem. But eventually the way out of the mess going to go upstream. And not only go upstream, but for the rest, make sure that all the data are made free and open source. We've not looked much at the license DB, but we maintain what is the largest license database in the galaxy. I'm very proud of this. You'll see any kind of funny stuff. You know, the tag and the hook for this webinar was this anyone but Richard Stallman license. It does exist. And you can see it. It's not super frequent. But the point is that it's weird and we can detect that. Or this other one, which is a Chinese license called anti-ICU, 996 ICU. 996 means if you work from 9 a.m. to 9 p.m., 6 days a week, which used to be the regimen in some Chinese industrial place, then you end up in ICU, intensive care unit, not the intentional code for Unicode. Funky license, and you'll see a lot of these like that. The point is that we want to be able to detect them because funky is not really something that meshes well with any serious software development, be it open source or for business. And at this time, we are done, and I'll take questions. I'm going to stop sharing my screen. And I'll take questions from the audience. All right. Well, I don't see any questions so far. So I think that'd be it for the day. Thank you very much again for your time. And I hope this was useful. The slides and the video of this webinar will be posted online. And I wish you a wonderful day. Goodbye, everyone.